Now we know what is HDFS. So in this part, let's talk about some related concepts that are very important. In part 1, we see that HDFS is a distributed file system. It means that it stores files on multiple computer nodes, and these multiple computer nodes form a computer cluster. Currently, the computer cluster used by the distributed file system consists of common hardware, which greatly reduces the hardware overhead. Here, let's talk about the basic system architecture of HDFS. The HDFS architecture consists of 3 parts: name node, date node, and client. The name node stores and generates the metadata of the file system. There's only one name node instance in the cluster. The date node stores the actual data and reports the status of themselves to the name node. There are multiple date node instances running in the cluster. A client supports HDFS access by service. It obtains data from the name node and date node and sends the data back to the service. In HDFS, a file is divided into multiple blocks. The block is used as the storage unit, and the default size of it is 128 megabytes. The block size of HDFS is much larger than that of a common file system, minimizing the addressing overhead. Using the block as the storage unit has obvious benefits. First, it can support large-scale file storage. A large file can be split into multiple file blocks, and different file blocks can be distributed to different nodes. Therefore, the size of a file is not limited by the storage capacity of a single node. Second, it can simplify the system design. Storage management is greatly simplified because the size of file block is fixed. In this way, it is easy to calculate the number of file blocks that can be stored on the node. In addition, metadata can be managed by other instances rather than being managed together with these blocks. Third, it is more applicable to conduct data backup. Each file block can be redundantly stored on multiple nodes, greatly improving system fault tolerance and availability. Next, let's talk about the difference between name node and date node in more detail. Name node is used to store metadata in the memory. It saves the mapping between files, blocks, and date nodes. That means it records the location information of different file blocks on different date nodes. While date node is the worker node of HDFS, it stores data in the disk and maintains the mapping between block IDs and local files. Also, name node manages the namespace of the distributed file system and stores 2 core data structures: fs image and edit log. Fs image is used to maintain the file system tree and the metadata of all files and folders in the file tree. The operation log file, edit log, records all operations on files, such as creating, deleting, and remaining files. Just now we see that date node is the actual working node in HDFS. It stores and retrieves data based on the scheduling of the clients or name nodes, and periodically sends the information of stored blocks to the name node. And data on each date node is stored in the local Unix file system. In this section, we talk about some basic concepts of HDFS. Next, we will talk about the architecture of HDFS.